Hello everybody, welcome to Jack Talk. Today is the session 10 of the digital system knowledge. I believe it's about to end this series, okay, because of the move on, next one, we're going to have some, hardware knowledge, going to have some internet, and knowledge to begin with. But today we're going to have something like a summary again for the digital system. See how digital system is applied to hardware. Okay, the very good example, very good thing is the CPU. You guys know about CPU, right? Good. What is a CPU? The name implies what? CPU is a central processing unit, right? Okay, central processing unit, that means okay. I believe I don't have to explain what is a central. Okay. What is unit, right? Let's focus on processing. CPU is processing something. So let's figure out what does a CPU in the computer process. Okay, because we discussed digital system already for many sessions, right? So the digital system only has two symbols for the computer, actually for CPU. Okay, 0 or 1. That means a binary system. So that means that the CPU has to handle in the format of binary system with only 0 and 1. So let's start with a very old CPU way back to 1980 when IBM PC show up in the world, because that's the simplest thing, easy to understand. But if you say the current technology, Intel and I-Core 9 now, many generation has been developed already before the current technology, I-Core 9, right? But don't tell me that's a more, complicated than the first generation of the CPU. More or less the same thing in terms of the architecture, in terms of the principle. Of course, just like the more and more 0 and 1, okay, less CPU to process, that's it. So let's take a look at what is the simplest. The first generation of Intel's CPU is called 8088. The CPU is like that, okay, 8088. So we have from here to here, from here to here, 40 pins. That's a 1. That's a 40. All the way down to 20. And here's from 21. Okay? So all those things, okay, will have to be assigned to something. So what we need for CPU processing, number one, of course, data. I want the CPU put a letter A on display. That's the simplest one, right? You punch the keyboard, you hit the letter A, and let the monitor show up with the letter A on display. That's simple, right? So we're talking about how CPU handle that. The 40 pins assignments from the 1 to 20 this side. So actually this one is a ground. This one is a VOC, is a voltage, the power for the CPU. And from here to here, we have some pins assigned to data. The data is from, let's see, they're from the 16. Pin 16, right? Pin 16 all the way to up to 9, sorry, it's 9, pin 9. Okay, I also forgot that assignment long time ago. So there's 8 bits, right? 8 pins. One pin represents 1 bit because each pin has only 0 and 1. Actually, it's either on or off, with or without voltage. Way back to many years ago, the voltage is a 5 volt. With 5 volt means 1. With 0 volt on that pin, a certain pin, there's a 0. Okay? Use that kind of format to represent 0 and 1 because 0 and 1 is a mathematical concept, right? So we use the electricity, just like I mentioned that way back to the session 1. We like the electrical voltage to represent something. Okay, so from here to here, we represent data. Data from 9 to 16. Okay, let's continue. From 9 to 16, there's 8 pins, right? Including 9, including 16, not minus. Okay, so 8 pins means 8 bit. And 8 bits represent the X key code. Because the 8 bit equal to 2 to 8 equal to 256, we have 256 combinations assignment to English letters, you know, the capital letter, the small letter, okay, 26 plus 26, 52, and plus some other symbols like the plus minus or something like that. All those are like the comma, full stop, all those things. 256 is fair enough. So each symbol in human language, a very basic communication, 256 combination of 0 and 1, okay, were enough at that moment, way back to 40 years ago. But now, of course, not, right? Okay, now figure out 256, that's the data. And from here to here, because they take turn, because under the control, they take turn, they have some pins here is 16 pins, and here's 4 pins, and then got 20 pins. We assign the 20 pin to be 20 bits for what? For addressing. Because we do need address on memory. Now think about that. If somebody asks you to get something for him or her, he or she has to let you know where to get the item, right? So that means whenever you're going to get something, like the CPU going to get some data, at least have 2 things. Number 1 is what it is, the item. In computer technology is the data. Second thing is the address, where to get. That means address. So they assign 20 pins. Now remember, we said whenever we say n pins, n bits equal to 2 to that number as exponents. Okay? So 2 to 20 equal to 2. What? 220 equal to 210 times 210 equal to 1 meg. 1 million. Be careful, the million is not the decimal million. It's a binary million, a little bit more than decimal. You understood already, right? Okay, good, perfect. Now, 1 meg is a very small quantity today. But all the way back to 40 years ago, that's a lot for memory. So memory has addresses, okay, for the CPU to handle. So only 1 meg memory. Okay. How about the rest? Because we have a data, we have address here, all the rest pins. Because here we took 20 something, still have pins left, right? We assign as control. What is control? Just like the traffic lights. Because the CPU moving around the data, sometimes you need a letter A, sometimes a letter B, sometimes you need a comma, something like that. Okay, CPU move data around and pick up something here at this address, pick up something there at that address, right? So we do need the traffic control. In other words, that means traffic lights. So we do need that kind of things to handle. Make sure everything be processed regularly. Okay? So there's 3 buses on CPU. Number 1 is a data bus. That's a very important concept. Data bus. And then we have addressing bus, address bus. And thirdly, we need control bus. So 3 buses. Is how CPU control is processing. So when we say CPU, central processing unit, if you ask, what does CPU process? 3 things: data, address, and control. That's it. No matter 40 years ago, very old, very small, very basic CPU, or today's advanced, okay, I-Core 9 from Intel. Now I believe, if I'm not wrong, I believe it's the Intel I-Core 9 has 1200 pins compared to only 40 pins. Increase a lot, right? What they're used for? Because today's computer need more information, more big rooms to handle, right? So that means you need more data, you know, and data information, and more area. So that's why we need more addresses and more controls, right? Agree? So that's why and what a CPU is. Okay? So I'm trying to give you guys a picture, a concept, why we need a binary system, just like the CPU, right? I believe they will make a very good start. Let's moving forward to some hardware component. Then the internet knowledge can help you build up your knowledge base. Okay, something like the systematic knowledge base for you. And try to build up your self-taught capability for the high tech, for the current, technology. Because just like what I said, the self-taught is extremely important these days. Okay, see you guys next time. Thank you.